Okay, we're going to be looking at the review for Unit 5. If you do not have a copy of this review for any reason, you might want to go to It's Learning and print a paper copy of it. I'm not going to work all 44 problems on the review simply because the video would get tediously long, but I'll kind of pick a few in each section, maybe the harder of the problems, and kind of show you what the expectation of quality work will look like for the exam. All right, so we're using this number line to answer the first 13 questions. And the first thing I've asked you for is the distance or the length of DB. The distance from D to B is the same thing as the length of the line segment DB, right? So you probably want to remember that in order to find length, we can take the absolute value of D minus B. And I realize that many of you could count and see that this is 1.5 units, so I should expect to get 1.5, but I would like to see this formula being used to find the distance. Okay, so I'm looking at the absolute value of the coordinate of D, which is -2, minus the coordinate of B. All right, so it's halfway between 0 and -1, which would be -1/2. And I can choose to put this in the calculator just as is, or I can do the arithmetic by hand. So this is the absolute value of -2 plus 1/2, right? So minus a negative becomes plus. And then -2 plus 1/2 is -1.5. You can work in decimals if you prefer that as well. So we're looking at the absolute value of -1.5, which is, I apply the absolute value and it comes out of the absolute value as 1.5 units long. Okay. So the entire first row are worked just like this. You're just subtracting the endpoints from each other and it's giving you the distance. So let me do the other one that has the fraction in it that's been bothering people all day. So if I want to find the distance from B to A, or the length of the line segment BA, then I'm going to take the absolute value of B minus A. And before I even begin this process, I might want to check to see what the length is, right? So 1, 2, 3.5 if you count from A, or 1/2, 1.5, 2.5, 3.5 if you count from B. You should get the same thing whether you count from left to right or right to left. Remember, distance is always positive. So BA is going to be the absolute value of B, which we already determined was -1/2 or -0.5. So that would be -1/2 minus A, which is 3. So if we have the same signs, then we keep an add. So that would be -3.5. And the absolute value of -3.5 is just 3.5. Right? So the length of the line segment of BA is 3.5 units long. Okay. Whole first row worked exactly the same, not super difficult, right? And if you want to try them now, then maybe you should pause the video and I will throw the correct answers on there. So if you pause now. Okay. So if you've just worked those, then your answer for DA should have been 5 units. DC should have been 7 units. And number 5, you should have gotten 2 units. Okay, hope that's helpful. All right, moving on to the next set of questions, which are asking for the midpoint of DA. And I should be able to just go up here and sort of count off the midpoint, right? D to A is 1, 2, 3, 4, 5 units. And so half of 5 is 2.5. So halfway between would be 2.5 units between. So 1, 2.5, 1, 2.5 would put me at, looks like +1/2. But we do have a formula for this that I'd like to see you apply. If I want to find the midpoint of DA, that point right in between D and A, then what I will do is I will add the endpoints from D to A and then average them or divide by 2, and that will put me right in the middle. Kind of like finding the median, right? Finding right in the middle. Okay, and so D is -2 and A is 3, and I would divide that by 2. And so I end up with 1 in the numerator divided by 2. So it turns out, you can see from math as well, from this math and from the picture up there, the midpoint of line segment DA occurs at 1/2. And all of these are worked the exact same way. So if you wanted to pause the video now and try 7 and 8, that would probably be helpful. All right, so AC is going to be taking the endpoints A plus C and dividing by 2. A is at 3, and C is at 5. 3 plus 5 is 8. 8 divided by 2 is 4, right? So just getting 4 here. So the midpoint of line segment AC is going to occur at 4. And just a really quick check here. When I look at AC, right, AC, this line segment, right, it kind of makes sense to us that 4 would be right in half. So I would recommend when you do this, go ahead and check and look and make sure on the picture that what you're getting makes sense. And if you work 8 in the same manner, you're actually going to get 2 and 1/4, right? So I'll go ahead and do it since it's actually the hard one. I should have done this one. B plus C divided by 2. All right, so B is actually -1/2, and C is 5. I'm going to carry this in a little further. 5 minus 1/2, which is basically what's happening there, is 4.5 divided by 2. And if I think about what's happening here, half of 4 is 2, and half of a half is 1/4, right? If I take half a pizza and divide it by 2, I'm going to get 1/4 of pizza. And so it turns out that the midpoint of BC occurs at 2 1/4 on the number line. Okay, moving on. Looking at numbers 9, 10, and 11, we're comparing two line segments. So we're asking ourselves, is it less than, is it greater than, is it equal? And so in order to show quality work here, I don't want to go up here and count what's the length of DB, right? So in order to get credit for this, you would actually have to physically show me the math for DB, right? You'd have to say, okay, I know how to find DB. It's the coordinate of D minus the coordinate of B, right, which is 2 minus -1/2, and we already did the math actually for that, so I'm not going to do that again, but that is 1.5. And then I need to find the length of BA, and the length of BA is the coordinate B, which is -1/2, minus coordinate A, which is 3, which actually gives me 3.5. Again, we already did this math up here, so I'm going to go quickly through this. And so DB is 1.5, BA is 3.5, so of course DB is smaller or less than BA. So this is the work that I want to see. I want to see you physically finding the length, comparing them, and then giving me a statement based on that comparison. If you want to pause now, you can do that in work 10 and 11. And it turns out that when you find BA, right, you get 3.5, which we just did, and AC was 2, and so 3.5 is greater than 2. If you were to show me this on the test tomorrow, I would not give you full credit for it because you are not showing me where the 3.5 and the 2 come from. I'm just sort of showing you what you should get with the longer method. And then DB, when you find DB, you get 1.5, and when you find AC, you get 2, and so this one's less. Okay. All right, number 12 says, plot point R, which, by the way, when you look on the number line, there is no point R right now. Okay, so we're going to have to add that point to our number line. So plot point R so that RD is equal to DB, and then find that coordinate of B that you plotted. So we want RD to be equal to DB. So as I come up here, I'm looking at DB, and I have to have RD be the exact same length. And the length of DB is 1.5 units, which we already figured out, right? And so in order to do RD, I need to plot point R somewhere over here so that it's also 1.5 units. And I would just count 1.5 is here. And so this would be my point R, which is now also 1.5 units long. Another method you could use there is to take the coordinate of D and subtract that length that you're trying to go. -2 is the coordinate of D. Subtract that 1.5 length that you want to go, and that's going to give you -3.5 for your coordinate of R. And so you can sort of see that here in the picture as well, -3.5, or you can physically subtract. Okay. Number 13 we're going to do kind of something similar here, but in a different location. So we're going to plot point P so that CP is equal to DB. Right? So we're going to go up here and CP, so I'm going to add a point P to my number line up here. DB is 1.5, so from C I'm going to go 1.5, 1.5, and that's going to be where I put my point P at 6.5. Another thought behind that could be that if I want to go from C to P the same length as DB, then I start at C, whose coordinate is 5, and I add the length of DB, which is 1.5, and that puts me at a coordinate of 6.5, right? So you can see here that the same thing happened when I counted it out to get 6.5. All right, moving on to 14, 15, and 16. Using a different number line this time, we're showing that segment addition works. And so, again, I want to warn you not to do, okay, I know PQ is 2, and I know QS is 4. So I'm just going to say 2 plus 4 equals, and then count from P to S and get 6. Yes, I realize that you can count that. But I want you to physically show me that you can find the length PQ and verify it beyond counting, right? So that would be the absolute value of P minus Q. So the absolute value of, and I find the coordinate of P, which is -4, and the coordinate of Q, which is -2. And so -4 plus 2 is -2, and the absolute value of -2 is +2. Okay? Then you would find QS, so that would be Q minus S. And let's see here, Q is -2, S is +2, so we have -2 minus 2, which is -4, and the absolute value of -4 is +4. Right, so I've now shown that PQ is 2, and I've now shown that QS is 4. So now I want to find PS, and I realize I'm going to go into this problem a little bit. So PS is the absolute value of P minus S, and P minus S, it would be -4 minus 2, and the absolute value of -6 is 6, right? So I can sort of show you now that PQ is 2, QS is 4, and when I add them, I do get PS, which is 6, right? So I've kind of shown that this actually does work with the verification of distances. 15 is the exact same type of problem as 15 is the exact same type of problem as 14. So you can check the review online with the answers if you want to see that done. All right, 16 says, prove that R is the midpoint of PS. In order to prove that R is the midpoint of PS, then I want to show that PR, now what I'm doing here is I'm showing that here's PS, I want R to be the midpoint, so I need to show that PR is the same length as RS, because that's what it means to be a midpoint. It means it cuts it in half where you have two equal segments on either side of it. So if I want to find PR, right, then I would do the absolute value of P minus R, which would be -4 minus -1, which would be the absolute value of -3 or 3. And if I want to find RS, that would be the absolute value of R minus S. And the coordinate of R is -1, and the coordinate of S is 2. And so I end up again with the absolute value of -3, which is 3. And so because I have shown that PR is equal to RS, then I have shown that R has to be the midpoint. Okay, moving on. "17 says, what is the coordinate of the midpoint of DE if D is at -4 and E is at 9? Okay, well, we've done this a lot now. If I want the midpoint of segment DE, that means I'm going to add the endpoints and divide by 2. Well, the endpoint of D is -4, and the endpoint of E is at 9. And so that would be 5 divided by 2, which is 2.5 or 2.5. So that would be my midpoint. Pretty easy. All right. Number 18 says, S, M, and T are points on a number line. M is the coordinate. M has coordinate 2. Excuse me. T has coordinate 14. What is the coordinate of S if M is a midpoint? So here's what I have a number line where M is the midpoint of ST. Okay? And the coordinate of M is 2. And the coordinate of T is 14. And the question is what's this guy? Okay? So kind of what you want to think here is the length of this is 12, right, from 2 to 14. And you can find that by doing the absolute value of 2 minus 14, which is 12. And so if I want to find S, I have to create another segment that is 12, because that's what it means to be the midpoint. It means to create two equal segments. So I can do one of two things. I can count back from 2, right, to 12 times, 12 units from 2, like 1, 0, -1, -2, -3, -4, -5, -6, -7. I haven't gone 12 yet. -8, -9, -10. I think that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That puts me at -10 for my S value. So my S value is at -10. So you can see I've sort of created that 12 units. Another option you have here is you want to go left 12. So do 2 minus 12, and that will get you -10 a little faster than just counting. Okay. Okay, so then we're looking at, does PQ plus QR equal PR when you've got this information right here? So you've got coordinate, let's see if I put them in the right order here. Q is at 6, and R is at 8, and P is at -10. And the question is, does PQ plus QR equal PR? Right? So I need to find what PQ is. PQ is -10 minus 6, which is 16. So the length from P to Q is 16. I need to find Q to R, which is 6 minus 8, which is only 2. And then I need to find P to R, which is negative 10 minus 8, which is 18. And so, yes, 16 plus 2 does equal 18. Okay. Then it says, is Q the midpoint? No, it's not, because if Q were the midpoint, these distances would be the same. So I need to find the midpoint of PR. Well, that's okay, because all I have to do is take the endpoints P plus R and divide by 2. Right? So P is negative 10, and R is 8, and I divide by 2. Right? So negative 2 divided by 2 is negative 1, and so I say the midpoint of PR is negative 1. Oh, you can't see hardly that. Okay, I'm going to stop this video, and I will pick up number 20 on the next video to keep them from being too long. Hope that helped.